Can you explain the difference between shallow copy and deep copy in JavaScript?
Yeah, so in JavaScript, shallow copy creates a new object, but it only copies the top level properties. And if object has it nested object or array, then both original and copied object still refers to the same nested data. It means original and copied object still share the same nested object, and if we modify the nested object, it will affect the original object as well. For example, if we create object by using spread operator or object.assign, that means we are creating the shallow copy. And in deep copy, that create completely independent copy of that original object, and all nested object also created separately. So that means there is no reference are shared in deep copy. And so if we modify anything in the copied object, then it will not affect the original object. So in deep copy, like we can create a deep copy by using structure clone function. Also we can use the json.stringify method to create a deep copy of the object.
Okay. What are the promises and how do you handle promise chaining in JavaScript?
A promise in JavaScript is an object that represents the eventual completion or failure of an asynchronous operation and its resulting value. It is a way to handle asynchronous code more cleanly than callback. Like promises have a three state. One is pending, fulfilled, and rejected. So we can handle the resolved value by using .then method, and we can handle error by using .catch method. And promise chaining happen when we return another promise inside the then method, and each then method run only after the previous then method is finished, which helps to avoid callback hell and keep code more cleaner. Yeah, so in that way we can handle the promise chaining.
Okay, fine. Can you explain the async await and how it's work under the hood?
Okay, so async await is more readable way to work with promises in JavaScript. So when we mark a function as a async, it automatically return a promise, and inside that function we have to use await keyword. Await keyword we can only use inside the async function, so it pause the execution of that function until the promise resolved, and it will without blocking the main thread. So yeah, and if a promise rejects, the error can be caught by using try catch block. So which can by using try catch block we can handle errors in async await. So so at the end, JavaScript engine transform our async await code back into the promise change behind the scenes, and it's using generator and promises internally to manage the pausing and resuming behavior. So yeah, that's how async await work in JavaScript.
Okay, okay. What is generator function?
So generator function in JavaScript are a special type of function that can be pause or resume their execution. We define them using the asterisk sign syntax, and they use the yield keyword to pause execution and return value at a specific point. When we call a generator function, it doesn't execute immediately. Instead, it returns a generator object that implements the interior protocol. So each time we call .net next function, it executes until it hits that yield. So return that value and pause again. So the next time when the next function call, it's again resume the execution from where it left off. So JavaScript uses generator internally for to implement the pause and resume behavior in async await.
Okay, fine. What is debouncing or throttling? Can you give me one example of debouncing?
Yeah. So debouncing and throttling are two techniques used to control how many times a function is executed when it is triggered repeatedly. So especially useful for a performance optimization with events that fire rapidly, like scrolling, resizing, or typing. So let me explain you in different way. Like debouncing delays the function execution until after a certain amount of time has been passed since the last time it was called. It's like waiting for someone to stop typing before doing something. For example, uh, if there is a search bar or there is an input field, so each keystroke there is API call. So we should not call API on each key press. We can wait for a user to finish the typing, then we can call API. So that can be achieved by using a debounce function. So let me explain the code. How can we write debouncing method in JavaScript? So let's take one function, call it as a debounce, and that function will take two arguments. One is function and second one is delay. Okay, delay or timer. Okay, so here let's take one variable, called it as a timer, and this function return a function, and that function will take that arguments which are passed to the original function. So this can be this. Okay, this can. Okay, so this function we are so firstly for we have to clear the timer. So let's use the clear timeout. Okay, so in clear timeout we can clear this timer at first line, and in second line we can set the timer, like we can use the set timeout. Okay, set timeout, and this set timeout function can this we can pass a delay here, and here we can execute this function, like the argument function where we are getting as an argument. So this function we can pass here, and we can, like, yeah, this argument we can pass here. So what will happen here? So each time if user types something, this function will get called, and each time it will clear the previous timer and set new timer. So each time it will delay the function execution until timer is not passed away. So in this way we can create a debounce function. And in throttling, the function runs at most one within a given time interval. For example, for limiting a scroll event handling to fire once every 20 milliseconds, something like this. That's use of throttling.
Okay, fine. Can you tell me what will be the output of below code?
Yeah. Okay, so firstly it will print 1 immediately because it is a synchronous line. Then secondly it will print it will print a 4 directly because the set timeout and promises are asynchronous tasks. So first it will execute the synchronous task, which is 4. Then after 4 it will goes to the promises, because the promises goes to the micro task queue. So micro task queue has a higher priority, then that's why it will execute first before the set timeout. So it will print 3. Then last line, that set timeout function will execute, that is 2. So the sequence will be 1 4 3 2. So in this way this code will run.
Okay, fine. Let's move on to the CSS part. How does z-index work?
Okay, so z-index only work in the positioned element. So if element has a position static, that is the default position in CSS, so in that case z-index will not work. Z-index controls the stacking order of elements, so it's determining which element should be appear on top of the another elements if they are overlapping. So it means higher z-index values appear always on top of lower values.
Okay, what is CSS grid? And what is the difference between flexbox and grid?
So a CSS grid is a two-dimensional layout. In CSS, that's allow us to design layout using rows and column by using grid. And flexbox is a for single dimensional or one dimensional layout. Both can be work together. And in flexbox, it is perfect for a components layout where a navigation bar or aligning item in a single direction or distributing space between item. In that case we can use the flexbox, but if the grid is ideal for overall page layout, if there is a complex structure or when you need to precise control over the board dimension, then we can use a grid.
Okay, fine. Let's move on to the React part. What is the difference between use layout effect and use effect?
Yeah, so both are the React hook that's manage the side effects of React. So use effect run after the browser has painted the UI. So any DOM updates inside the use effects happen asynchronously and wouldn't blocking the rendering. It's good for a task like API calling or subscription, event listening, or logging, etc. And use layout effect run the use layout effect run synchronously before the browser paints. So this means the UI wouldn't be visible until the code finished. So it is used when you need to measure or modify layout to avoid flickering effect. So yeah, it will delay the UI from painting.
Okay, fine. What are the common performance issues in React.js and how you can fix those issues?
So the main issue is the re-rendering of a component. So in every time when component prop or state are changed, then the components are get re-rendered. But at the same time, if the component have a child component, that all child components are getting re-rendered unnecessarily. So we can avoid this by using the react.memo function. So if we use react.memo in child component, then that child component will only re-render if that prop or state are changed. So we can use that. Also we can optimize performance by using use callback hook or use memo hook if we have a expensive calculation in function. So that function we can use these two hooks. That execution of function will memoize, so it will not execute again and again if there is the same input we passed to that function. Also we should split big components into smaller components, so the state and props should be if we update any state, then all component will not get re-rendered. Then again we can use as we talk about the debouncing throttle, so that we can use whenever that is necessary. Then we can use the dynamic imports for code splitting, so it will import the component only if that component is required. So in this way we can split the code. Then we like lazy loading we can use. And I always used to use the DevTools profiler to identify which components are re-rendering unnecessarily and why it is re-rendering. So by using profiler, we can find out the performance problem and fix that problem. So these are the some common issues, and we can fix.
Okay, that's great. How does React decide when to re-render a component?
Yeah, as I said, React re-renders component when its state or props are changed. So React compare the new virtual DOM with the previous one using reconciliation. So if anything different in the component tree, then React updates the UI accordingly. So by default, when the parent re-renders, all childrens are re-rendered too. So the React re-renders when state props are changed, or if the context there is a context API in React.js. So if the context is changed, then also React update the DOM only when there is a virtual DOM, only when there is a difference in virtual DOM. So this is how React decide to re-render a component. Okay, fine. What are core web vitals? So core web vitals are a set of metrics defined by Google, and that's measure the user experience of a web pages. They become a ranking factor for a Google search. So there are important for there are they are important for both point of view, like UX or SEO point of view as well. This matrix helps to identify how quickly our page are loading and how responsive it is to user input. So there are mainly three main metrics included in core web vitals. One is largest contentful paint. It measure how much time it take for a largest visible content element to render. Then second one is first input delay. It calculate time from when user first interacts, like a click button or links. So to when like it calculate that time of interaction from the first user click to when browser can respond. Then third one is cumulative layout shift, like how much expected layout shift occur during the page load. So that the time it will calculate. So these are the main core web vitals.
Okay, fine. What is web accessibility?
Is web accessibility. So web accessibility means designing and developing websites that can be useful for everyone, like the people with disabilities can also use them effectively. So it's about ensuring all equal access to the everyone. So for example, providing a alt text in the image tag, so that can be easily read by the screen readers. Then again, if we are using the div as our button, so we should define the role equal to button to that div. Also we can use the area labels whenever is necessary. So this can be used for the screen readers, and we should use the proper semantic HTML, like header or section tag or div main tag. So we should use that. Also we can use the proper color contrast to the website. So it's clear focus on the indicators and meaningful labels. So yeah.
Okay, in React.js, what is the context API?
The context API in React.js is a way to share data across the components tree without having the prop to pass manually at every level. So it solves the prop drilling problem. So when you have a data that's need to be accessible by many components, means many child components, so at different so we can use the we can pass that data by using prop as well, but every time we need to pass the props to the each to that child component, then child component again pass that props to their child. So this will become unmanageable. So we can use the context provider there. There is a context provider and one is a context consumer. So the context provider hold and provide the data, so that data will available to all its child components, that we don't need to pass as a props, but it will available to all that child component tree. So any child component can access that data by using the use context hook.